Okay, well, let's do that. Okay, that is better. That is better. We almost had to cancel the show. GetRect is getting text introspection. No, because I don't know what that would entail. So that is not happening tonight. It may happen later. Tonight, I'm eating popcorn, and then we have a grab bag of things. And we're going to start with this example that those of you who were on a stream maybe a few days ago or whenever, I was like, hey, we got this example, and we ran it. And it was a cool skeletal animation example. And I didn't know if I had permission to look at the source and like audit it, because I wanted to look at it with the idea that it could be a new example program distributed with the compiler. And we have since got permission from the author of the program to do that, so we will be looking at it. But first, let's compile it and remind the people as well as ourselves what it does. Dude, the folders. All right, so we're gonna go here. And it's gone into bin. Okay, so we have Running Man. This is the Running Man, the game. Now I'm actually kind of interested in how is he doing the 3D rendering right now? Because like he's using GetRect here, and it's Pepsi Man. That's what it is, kind of. So it might be sort of using GL to do the 3D directly, which long term is maybe not that good of an idea because it's not portable. Maybe because we're not going to be using GL as the backend for simp forever. But as an example right now, that could work, and we could adapt it later if that becomes necessary. Anyway, I think it's a cool little example that does something practical and looks neat. Yeah, so here you can see these are the actual keyframes, and then this is interpolated. No, simp isn't DirectX. Simp is whatever it is. Simp is simp. It doesn't need to have eyes modeled, but it does. Okay, so this is what this does, and we have little buttons and stuff. That's great. Okay. So let's go look at the source. First, let's look at the metaprogram. Like, I'm not even sure why it's got one. Okay, that's my first comment. Okay, I already don't like this. I'm going to make notes about what I don't like. The author of this could also watch this later. Okay, the problem with the code we are looking at is if it sees an argument that it doesn't know, it silently fails. And that is very bad because it's just very error prone. It is not a good way to write software, broadly speaking, that if somebody makes a mistake, it silently fails. And so we don't want any of this in our example. That said, you know, it's fine. It looks like this is also maybe part of how he just keeps his compile, edit, debug cycle tight. It's like, oh, as soon as you compile, run it, and it's just one command. I don't know why not just do, because there's shell stuff where you go and then run, and it's conditional on, I don't know, but maybe you don't want to use shell. Maybe you don't want to know how any of that works. I sympathize. Okay, so this is all extremely questionable. Like, do you really need this? And some of these things now you could set. So if we don't need the rest of the metaprogram, the output factors can be set with build options during compile, which means you don't need a separate metaprogram for it. And if this is an example with the compiler, I would basically prefer that we don't, because if the point isn't to demo a metaprogram, then we could keep that out of it. Okay, so he adds main. Wait, this isn't fucking legal. Oh no, yeah, it is, sorry. Sorry, I got it the wrong way around. That is totally legal. In fact, it's required to do it in this order. Okay, so while true, we wait for a message. If it's complete, yeah, so this metaprogram does very little. It does very little. Now, what's the copy directory for? Yeah, I mean, okay, like, I understand why you would want to do stuff like this if it's your own program, but I think if it's an example, we leave this out of it. And so that'll be part of my feedback. Okay. What is the Blender? There's like Python stuff in there. I guess that's, oh, that's to export. You need to explain this stuff, right? Like, what is this? Right, and how do you use it? Is this something you wrote, or is this like a Blender thing that you're redistributing that has some, oh no, it looks like he wrote it. Is it possible for a bone to spawn in the middle of an animation? No game wants that. No game wants that. Okay, so this is like an exporter in Python. that Blender could run. That's, I guess it is what it is. So that's why you redistribute it, because you want to let people export. But there needs to be a README, like explaining these things. Like, what are all the files? What do you need to think about when? How do you compile and run the demo, right? Like, people, do they have to guess that the executable goes into bin? Like, just all that kind of thing. Okay. Let's see. Math matrices are row major. I guess that's a comment to himself. I don't ever, like, I don't even know, like, row major versus column major is just a weird thing that I just don't think about that much. It's like you do it once and then you never care. Okay. Handle window event. Pretty straightforward. I don't know if we should put Alt F4 handling like centrally. I don't know what to think about that. For now, you do it yourself. Showing or hiding the cursor based on whether camera is going. Okay, so we init fonts. Yeah. Find and load assets, like what even are assets? It would be good to comment, that kind of thing. Okay, this is a file visit function. So visit files here is like it's a file utilities function that we provide, and you pass it the visitor function, and it basically runs this for every file that it finds. I guess recursively, probably. This is probably the recursive parameter. So if it's a directory, we don't care about it. If it's a mesh, I mean, I guess this is a fine way to do it. It's a little bit funny. This is a little bit error prone just because this is here and here. It's probably fine, but it's one of those things where, like, I would just use the path extension stuff or whatever, especially since we're already importing file utilities. Anyway, so we load the mesh from the file. We put the lotion in the basket. I've got to say, I'm not going to be picky about spacing. You know, if somebody submits a sample program and we use it, we're not going to like reformat it because we're not Go. But like, I don't understand why people like this spacing. Does somebody want to explain why people like this? Because it looks so weird to me. I don't understand. I don't understand. The people are welcome to use whatever spacing they want. I am not the spacing police, but I just don't understand. It's like, I don't know why French food has so many white creamy sauces. I don't want any of those white creamy sauces. Does Alt F4 already exit a window? I don't think so. Easier to tell scope? Easier than indentation? You thought that's a Windows thing. It doesn't happen. I think if you run, I don't actually remember, for example, if the simp example handles it, but if you don't handle it, I'm pretty sure it doesn't happen. But that might be some side effect of how we're creating the window or something that I'm not thinking about. Go format is a godsend? No, it's not. No. Fuck off with Go format. And like, I think Rob Pike is cool. I think he's a good guy. Fuck off with Go format. Just no. Because what it means is there's no room for style or personal expression. Okay, I'm going to go on this rant again. I've given this rant here before, but like, look, when you're programming, the code that you write is basically your house. It's the house in your mind, right? And what Go format says is you're not allowed to decorate your house. You can't make your room look like the way that you want it to, okay? It's like Danish modern furniture with brown curtains, and that's it. That is the only thing that you get, okay? And if you pull the rug over and move the couch, we're gonna fucking move the couch back where we put it, because fuck you, you don't get to decide where the couch goes in your house. And programming is my life. I want to decide where the couch goes in my house. You know what I'm saying? Because like, it makes me more comfortable. It works the way, you know, maybe I want some space in the middle of the room to put my yoga mat or whatever. It's my life. And I think it's just the wrong decision to say that you don't get a choice in that. It's one of the, okay, so a lot of times, I doubt that they thought of it this way, but a lot of times there are choices made in programming languages and systems that are made to like reinforce the goodness of the median case. You know, if you think about things happening on a bell curve, but that limits and restricts the outliers, right? Both on top and bottom. And the problem is that most productivity comes from right end of the curve outliers. In like any kind of power law discipline, of which programming is one of them. So if you restrict the right end of the bell curve in a way that you don't compensate for with other things, you're limiting overall productivity, because this is a power law scenario, right? So small adjustments matter tremendously. If you let engineers decorate the rooms at Fang, you'd end up with Gaudi. Yeah, but like, but if that makes your 10x engineers slightly more productive, then your company is twice as successful. Like, okay, let the medium people who aren't really invested in programming as their life do slightly bad things. It's fine. It's fine. Like, you need you need to let your aces be aces. You know what I'm saying? And being an ace involves having an opinion. "10x engineers, they aid the team, not ride as cowboys." Oh, just get out of here with all that rhetoric. All this modern communist rhetoric can go jump off a cliff. You please don't jump off a cliff, because we value your safety and livelihood, but I don't want to hear that stuff here. All the rationalizing about how good programmers aren't really good, or they can't do that much by themselves, almost every major programming project you hear about was somebody doing something by themselves up till it got to a certain point, and then a team got put on it to like maintain and support it in the big phase. But like pretty much anything that was ever successful was one person doing a thing. Like, I don't know, Unix, and then Linux, right? And the Git that you guys love so much, right? Like, original, new, powerful things are not usually team endeavors because teams, again, teams designed by committee, and design by committee tends to drag things toward the mean, right? Even if you had two people on the committee who have amazing visions, those visions point in different directions from each other. So you average them and you get like mush. Okay. That was our daily anti-weird millennial communist rant. Is there a word for fantasy communism or whatever it is? There needs to be a term for that specific thing. All right. I guess the term is American culture in the year 2030. Sag. Sag. All right. Anyway, let's continue looking at the example rather than talking about fantasy communism. Okay. For all I know, the author of this code is a card-carrying communist. It could be. It could be. Okay. If ends with info.fullname, .anim. So, okay, we care about two different kinds of files, mesh files and animation files. This is a very classical structure, right? In a game, you have a mesh file, which is the geometry without the animation, and then the animation file, which applies motion to the skeleton, right? And then part of what's in the mesh file is a mapping from vertices to bones, so that as the bones move, you know how to move the vertices. This has been the way it's been done since at least the 1990s, maybe even the 80s, I don't even know. Maybe the 70s. Like, it's a pretty old way to do it, but like, it's not really broken, so we don't worry about it. Okay, so we do our same funny thing here, and then we load the animation from the basket, and we log an error if we can't load it. Otherwise, we just put it in this array. So we just, oh, it's a hash table. Yeah, so we've got a hash. I mean, for this one example, there's only like two of each. So hash table seems goofy, but like if it's an example of how you would do it in a real program, it makes sense. And probably on his own program, he has a lot more data. It's just you don't want to distribute all that data necessarily with the example. Although I would maybe put one more animation in there just to do it. It's just because the idle doesn't have very much motion. So having a third animation would be nice. Okay. So this is where we visit the files and apply that function. So asset names arrays. What is this? So we make an array. Element 0 is a thing called none. And then we iterate over the hash table and put this in there. I guess that's fine. You could have sort of put them in here, but maybe he didn't. Like, this is maybe a little bit more efficient because you're not resizing the array multiple times. Because like by the time you get here, you know how big it is, right? Okay. Anyway, so this is obviously so that you have an ID where 0 means there isn't one, right? Fine. So this is this comment is kind of ambiguous, right? Start with a mesh and some animation. What does start with mean? It means probably that this is what is going to be the selection in the drop-down box. But this comment doesn't really make that very clear, right? So we just want to say like, hey, these are the things in the drop-down boxes. Maybe it says gparams. Where's that defined? It's like gpolice. All right, I don't want to search for it. It's not in this file, probably. Okay, so we make a window. We simp set render target. We set up get rect. We init our fonts. Init rendering objects probably does for the 3D stuff that he's doing. We'll see. Find and load assets. That's going to do the file visit stuff we just looked at. This initializes the camera position. Yeah, so he's doing direct OpenGL stuff, which long term I don't love, but we do not provide a simp 3D right now, so there's not really any choice. He's got to do what he's got to do. Okay. G running is a weird, see, his animation is running, and then this is actually the program is running. So my brain got a little confused about that. Maybe not that big of a deal, but my brain went there. Okay. This is not the right way to do this. This is not the right way to do this. Oh, wait, actually, I see. I mean, okay, here's a philosophical argument that I've had about how this get window resizes should work. I don't actually remember what I decided last time, but like, as resize events come in from the operating system, we could either aggregate them or not. Maybe that should be a flag and it just defaults to aggregating, because then you can do stuff like this. The only reason this isn't necessarily good is like, what if there's 5 resizes for a particular window? That said, I'm not sure any of the other demos do it better either, so I take that back. Anyway, this is a thing to think about, but I think for the purposes of this demo, actually, now that I think about it more, it's fine. Okay. Window events, that's just input and stuff. Okay. Update flying camera. Like this code, it's a few different things happening, right? Like, here's standard per frame stuff that you would do in any program. And then like here, we're starting to get a little bit application specific, right? And then here, it seems a little bit backward to me to use. This is a little bit of a slow way to do things where we get the index from the dropdown, we get a string name from the index, and then look up the string name in a hash table. Again, I think it's fine for a demo, but I would actually put a comment here that like, well, it's a little slow to do it this way, right? But the other point I was making is just, maybe I would have some comments like, okay, this is kind of stuff that you would do for anything, and then this is some very application-specific animation stuff. Just to have a little boundary in the thing. Okay, so if we loaded our mesh correctly, make pose for skeleton, I assume that this is, I actually don't know what that means. What is make pose for skeleton? Why are we making a pose for a skeleton? I assumed that that was playing the animation, but it's not. If this does some allocation or something, it seems like it does. I'm not sure why, but okay. Okay. We're advancing time in the animation. You know, this is weird. So with me, I use vertical space to communicate conceptual relationships, and other people don't seem to do that, and it's so weird to me. I'll explain more in a second. I have to eat this popcorn. Like, okay, here we're doing a specific thing from here to here. We're advancing time, totally cool. Here, different thing. Here's some skinning matrices, and we're gonna generate them. What, like, there's like not even a blank line between these. So to me, it looks like this is supposed to be like a whole thing, but this is two different things. Like, I don't know. Like, I'm going to undo this in a second because I don't think you should passive-aggressively edit spacing in other people's code. But, like, this is what it would look like if it were my code, right? It's like, here's a thing, and then here's a thing. And I would even do that. Oh, he's using tabs. I would do that, right? And it's like, well, and if we're really showing my spacing, I would do all this. And I think like this just communicates groupings better. It's like this is a thing. This is about advancing time. This is about getting the matrices, right? But not my code, not my coin. Oops. All right. All right. We do directly some GL stuff, which again, in the long term, once we introduce Simp 3D, we would probably change this part of the example to use that, but I don't know how far in the future that's going to be. Okay, we draw a mesh if we have one. Coordinate axes. I think it's kind of bad form to use functions to generate vectors for constants, because it just generates procedure calls and stuff. I would use struct literals for these. And it could even, depending on how you write it, I'll show you different ways of writing this, right? So just for this top one, this sort of naive way to do it, actually we have to look at his draw line just for a second To make sure that it actually takes vectors, it probably does. Yeah, so yeah, so it takes vector 3, vector 3, vector 4. So I at least would do this, right? And why would I do that? Because these are different. Like this is generated at runtime, all this, and then you're hoping that the optimizer does good things. Whereas these are all generated at compile time, and they just get passed by reference, and it's like way faster, even in a debug build, right? But then if you want to have a different style, you could even do this. You can be like, okay, that one's 0. This one is x equals 1. This one is x equals 1, z equals 1, right? Which is like a little bit more of like a, it just depends. It depends on what you want to see, right? So this one, like if we put this back down here, this, like it looks a lot like matrices, and if you like matrices and stuff, then this makes a lot of sense to write it this way, which is also how this literal version would look if you wrote 3 of them in a row, right? This one, if you did, Emacs is jumping all over the place. If you did this that way, it would look a little different. You would go x, y, z, and then, oh, this one, sorry, these are not z equals 1, these are w equals 1. I goofed. Anytime you change code, you might introduce a bug. But like, which one's better? Oh, actually, wait, are those vector 4s or quaternions? They're vector 4s. If it was a quaternion, we could leave out the w equals 1 because that's in the default value. But vector 4 doesn't have a default. It's 0. I mean, so yeah, like if you like shorter and talking about coordinates, you could do this. If you like matrices, I would write it this way with all 3. And it's, you know, like I said, it's sort of up to personal style there. Okay. Glad you liked the interview. The full numbers help drawing it in your head while checking where it gets drawn. I mean, sure, yeah. Like, there's advantages and disadvantages to both ways. Okay. So this minus 10 to 10 is just going to be drawing some grid lines. Now here, okay, here you actually couldn't use struct literals for these two because they're dynamic. At some point, we might introduce like a dynamic struct literal generation thing, but like, I don't know, if you're a performance programmer, maybe you like to see the braces and know that that means that there's no runtime computation. So that's sort of a question in the language, but so this is drawing those lines for the grid. And then we draw the skeleton. I don't know. So matrix 4 identity is, it's a constant matrix that's defined in modules math. So maybe this is multiplied by the thing or whatever, who knows. Okay. And then we do our end frame kind of stuff. Is a key down? Yeah, I agree that like, so this one, I'm pretty sure we do have cursor show and hide somewhere, don't we? That's a good question. Pretty sure we have those. We definitely do them in Sokoban. Question is, do we do them anywhere else? I don't know. Anyway, set mouse position, I'm pretty sure we have those somewhere. Anyway, a decomp. This is not a good way to do it. I don't think. It's been a long time since I've thought about this, so what I'm about to say may be wrong, but I believe that if you have non-uniform scale or shear or anything like that, then the rotation that you get from here and the scale that you get from this are gonna like not be orthogonal to each other, and then if you multiply them back together, you won't get the same thing. Like you'll get results that you don't want, I think. Which is why we provide a polar decomp in modules math, which is what I recommend anytime you want to do this operation, is use a polar decomp. I always found that to be the best thing. So this, I don't like that one. Okay. Hearing Matrix 4 reminds you of the movie. In San Francisco, they have the coffee shop where the Matrix 4 took place in the coffee shop, and you can go there. It's one of the only businesses still open in San Francisco. All right, so that's the end of main. It might take a while to go through all these files at this rate. We might have to crank faster, although some of them are smaller. Render, let's look at that. That's a biggie, right? Render, it's got a bunch of OpenGL stuff, I'm sure. Init rendering objects, blah, 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 blah. Check link errors, okay. Right, because you can't, in modern GL, you can't just have a shader. You have to do a program. You have to do all this stuff. Like, again, to me, this is kind of a big block of things. I would like to see, I mean, I guess the comments sort of tell you. Yeah, I guess. I get, yeah. Okay. So draw a line, start, end, color, color, okay. So this is, I guess this is a modern way of drawing lines in GL. Yeah. Anyway, when we do Simp 3D, we're going to have to think about providing ways of doing these things. But again, that's a longer term project. Draw a skeleton on a peloton, draw a joint, draw a pose. Like all of this stuff, the problem is you have to assume if it's a sample program, you have to assume that the viewer doesn't know what any of this, like I look at this, I know what it does. I've done all this stuff a bunch of times. I know all these things. Someone just looking in here isn't going to know any of this stuff. And so just a little bit of explanation on each function about, you know, what's a joint, right? What's a pose? All that kind of thing would be very helpful for beginners. Even just all this GL stuff. Like it just sort of assumes, it assumes that you know what is, you know, what a shader is. And since it's a sample program, we could probably use a couple sentences that say, a shader is a program that runs on the GPU. We put it there because it's faster by a lot than if we do this on the CPU. OpenGL requires us to make them to draw things. Here's, we make a few different shaders, you know, just a few sentences like that. Just to like get people there. Because most people, even most programmers, have no idea. If you haven't been introduced to 3D rendering, you look at this and your eyes would just glaze over, right? If you are familiar with 3D rendering, then it's normal and it's okay, yeah, whatever. But if you're not, it's just like, oh my God, what is all these things? There's all these words that I don't know what they mean. Okay, here's shader text. You could even say following is text of the shader programs. They get compiled above in whatever function, right? Okay, that's a pretty reasonable though, you know, so it's fundamentally kind of messy to have to like plug into simp with your own GL stuff. But given that that's what you have to do right now, this seems fine. Like, it's just GL makes you do a lot of things. So here we go, right? Totally fine. Yeah, I just feel like it could use some comments. Are we waiting on Simp 3D for a release? No. Why does everyone assume? Okay, parse, what is this? Is this loading the file, the animation file? Parse int. Parse int tuple, parse float tuple. You know, there's some code that we have for files with variables in them that we probably want to ship as a module. And this looks like a tweak variable format or something because we didn't give people one, so you implement one yourself or something like that, right? We'll see. We'll see what the other files do. Or maybe it's just loading the animation file. Joint sample, joint animation, sample animation. This is not really the right way to store things, unfortunately. I actually stored things this way as well in the current code, but you don't want to store it this way. Why? Because so the way you evaluate an animation is you're evaluating it at a certain time. You want to know where all the bones are at that time, and actually two neighboring bones at neighboring samples, and then you interpolate between those two samples, right? So in terms of memory locality, which is going to matter a lot, you want the samples for one frame near the samples for another frame. And that means you want to store them by bone index, right? So you have all the bones at frame 0, and then all the bones at frame 1, and then all the bones at frame 2, and then all the bones at frame 3. This is, actually, I have to remember to check if I actually changed it in ARC stuff or not. This is the pathological way. It means that when you go do a sample for a frame, you take, I don't know, 50 cache misses. I mean, maybe the CPU is going to be good, and okay, if you allocated it as a block and you have the same number of frames for all the bones, which you should, because that's just what makes sense, then it would be a constant stride and the CPU might figure it out. But these are probably allocated as a separate array per joint, which means they go somewhere random on the heap, which means the CPU can't predict. So you just take buku hash misses doing it this way. Cache misses, not hash misses. You know what I'm saying? Cache merces. Merces. Is that because it is a dynamic array? No, I mean, this isn't necessarily, so it could be that it's allocated as a big block and this just points in there. I just suspect that's not true, right? I suspect. We haven't visually verified. We don't know. Okay. So a skeleton pose is an array of joints. Yeah, I mean, this is not the way that you want to organize it for performance. Unless I'm missing something. Load animation from file, parse joint, consume next line. This is not good. This is not good. Let's go back to the parse file for a second before I say any more. Okay. It is good. It is good that we report errors in here when they happen. And the error function, I assume this is error out probably calls error on text file handler. Error out is probably something he defined. Yeah. I don't know. Why would you bother doing this? Oh, just so you can return. This returns false, so then you can return. I don't think that's worth it, but okay. Anyway, I'm not saying change it. It's fine if that's a stylistic thing you like to do. So it's reporting an error on the correct line. The thing is, it doesn't ever stop if there was an error. So if you're just sort of, and okay, these are exporter generated files, so it's not like they really should have errors. But if there is one, you're just going to spam errors for like 1,000 lines as soon as you have an error. And that's not really good. You should probably check at least once a loop if any of these failed or something. That said, ideally, you know, I don't know. I'm not going to go more into it. So it's a little slower to check, but it's worth it in terms of saving somebody's sanity sometime. Now, that said, for a production game, you don't want to load animations as text anyway. You want to load a binary file. But for a demo like this or an example program, a text format is totally fine. Out of curiosity, if everything were allocated in a big block, wouldn't it load a cache line from timestep t and a line from timestep t plus 1? So everything is in the L1 cache, irrespective of whether it's strided. No. How would it know to load t plus 1? Until you tell it. I mean, yes, okay, look. Here's another way of saying what I'm saying. If you have it stored by time, which is the way I'm suggesting, right? And then you have all the bones, all the bones, all the bones, right? Then you're loading, you're basically, so also the way this loop tends to look for evaluating the animation, right, is you're iterating over all the bones from 0 to whatever. And then you probably blend them together based on the hierarchy and stuff, but that probably comes later because the first step is interpolating the animations. And then you probably don't multiply them by the parent at that time when you initially interpolate, because in a more advanced animation, like the way that you combine things, you might have masks and whatever, who knows. You might do IK on things, and that just tends to be a separate function, like who knows. Okay. So if you do it by arrays of t equals 0, t equals 1, t equals 2, and then every bone is an element in the array, then the number of cache lines you use, you basically run, for each bone at time 0, you're running a cache line from left to right across that memory, which the CPU is very happy about. It'll prefetch, all that's good. And then the same for t equals 1. So you kind of take 2 cache misses, and then it goes, and then hopefully your prefetching is fast enough or whatever, right? If it's the other way around, if it's every bone is a separate array, and then you have t equals 0, t equals 1, then maybe both of those fit in the same cache line, but they probably don't even. Because like right here, we have position, orientation, scale. This is 3 floats, this is 4 floats, this is 3 floats, right? That's 10 floats, that's 40 bytes. So 2 frames of this animation is 80 bytes. What are cache lines? Are they 32 or 64 usually? Let's say they're 64. Who knows? It's still 2, right? So you kind of take 2 cache misses right away for one bone, because you can't really do anything till you have all these numbers, right? And that's for t equals 0, t equals 1. But now it's 2 cache misses per bone because you go to the next bone and they're gone, and the next bone and they're gone, and the next bone and they're, right? So you have to just do them all. It's way more cache misses. And then you might say, well, t equals 1 will be in cache for next time. But like, you're going to do so much work before the next frame in a real program, it's going to be long gone out of cache every time you show up to do this stuff. 64, yeah. Yeah, so if you need 80 bytes, that's 2 cache lines. That said, maybe I'm thinking about it wrong. It's not like I actually went in with an analysis tool and came up with what I just said. That's just what I said is my understanding in my brain, and sometimes our brain is wrong, right? But it's just to say there's probably a right way and a wrong way to do it. Okay, here's a comment. I like this. Text file handler interpreting starting with a hash character as a comment. By default, it also reads first characters. Like, okay, I'll say there's one thing I like about this example. Is it's a good medium-sized example, by which I mean, you know, you could have like small-sized examples which have one point. It's like, here's how to open a window, right? Or here's how to use assembly, right? This is a bigger program than that. It's doing a bunch of stuff. But the goal is like, here's without much fuss and much extra bloat, here's how you do this kind of application, right? It's an application example. And so far, I like the fact that it's pretty straight and to the point. Like any of this code that I look at, it's like, yeah, I see what that does. I see why it's there. I do agree that it should be there to implement this functionality, right? Which sounds easy or obvious, but like, if you've ever looked at Microsoft sample code or something, there's just like giant amounts of bloated framework that do nothing, and it's a disaster. It's like hard to find the point that you care about in like Microsoft samples. Whereas here it's like, okay, right away I started reading it and I understood all the things. Okay. So we only handle version 1. And yeah, these are some of the parse routines we saw. Joint animation times joint count. Yeah, so parse joint is being called separately on each joint. So it is very, very likely. We could go back and look, but, oh, it's in a different file. Where is it? Oh, it's, wait, what? I see, there's one for each. Parse joint in, oh, it was up here. Yeah, so we're making a separate array of memory per joint, which means it's bad cache performance. But do you know what? It's not as bad as an object-oriented person would make it, because they would have a separate object per translation and per rotation and per scale. So it would be infinitely worse if it was a modern C++ person, but, you know, yeah. Okay. Make pose for skeleton. What did this? Okay, this I don't love this. He was doing this with temporary allocator. Is this legal? Wow. I'm not actually sure if this is legal. But if it's illegal, we don't catch it unless you use it. So, no, it is legal. I remember making it legal, right? It's just, I was using this pattern a bunch in BASIC, the module BASIC, and then it was a bad way to do things for that application, so I stopped doing it. For this, you know, for user level code, it's probably fine. Okay. Yeah. So this is making an array of like joint transform data, and I don't know why he's doing that as opposed to just having a couple of globals that you do the thing into, right? Maybe thread safety or something, but I still wouldn't dynamically allocate them every frame. Like the thing is, if you're going to render a skeleton, you know you're going to render it every frame for a long time. So like the storage should be somewhere attached to the skeleton or something, in my opinion. All right. Reset to bind pose. Boom. That's for probably when you pick animation none. Interpolation mode, yeah, those are the things you can pick. That's cool. Interpolation joint samples. So nlerp shortest, again, you really need to at least have a comment explaining what the heck. Anyone who doesn't have game industry experience is going to have no idea, especially nlerp, dude. But what these are, okay. So slurp is you're interpolating your way around a sphere. It happens to be a 4-dimensional sphere defined by these two quaternions, right? Why? Well, actually, well, no. Okay, the arc around the sphere is defined by the two quaternions. Why? It's the same reason. So on the Earth, for example, which is the surface of a 3D sphere, right? If you pick 2 points on the Earth, there's one shortest path, usually, right? Unless they're on exactly the opposite sides, in which case there's 2 shortest paths. But then, or sorry, an infinite number of shortest paths, because they're all the same, right? The great circles. Now, when you have quaternions, you can't actually have that opposite side thing, because quaternions, the way that we use them in graphics, opposite sides are actually the same quaternion. Like a quaternion multiplied by -1 is actually the same thing. So the shortest thing here is about making sure that the two things are on the same side, and if one of them is on the wrong side, you just flip it to the other side. That's what all this is doing. People are going to have no idea. Okay, so, and then this is for the different ways you might interpolate. Totally makes sense. Totally makes sense. Except people are going to have no idea why you pick different ones. Again, if it's not like you could have quite long explanations for this, probably not necessary. You could probably just say, well, the right way to interpolate things to get results that humans like is this, and here's a reference. Here's a link or a book you can buy that explains all the things, right? Okay. Sample animation. So this takes a time. This is going to be the target where we put the memory, and this is how we do it, right? Okay. Name to joint ID. Ugh. Okay. I mean, I would at least, this is kind of fine. I would at least put a comment here saying, in a real program, you don't really want to do this every frame, this hash lookup. Instead, what happens is you just maybe when you load the animation and like start using it with a skeleton, you figure out the mapping, and then you just have an array that goes to skeleton indices. We actually do that in the Sokoban game, but it's kind of dumb, I think, for our purposes at least, because like I think when the animator changes the skeleton, they just re-export all the animations anyway. And so all those animations will be up to date in terms of bone indices, right? Maybe. I actually would have to ask the animator about that, but I think there's no reason to do it, but we do it. But there's especially if you're, if you're rendering a lot of dudes, you don't want to do this per dude per frame. Per bone per dude per frame. It's like, it's a lot. That's unnecessary. But again, it's fine for an example because it keeps down the complexity of the example. So you could just have a one-line comment or 2 lines that says, hey, for simplicity, we're doing this. You could pre-build this table or something. Okay. So anyway, we say this equals interpolate. Yeah, okay. First, second, I mean, this is pretty clean looking. Like, I understand exactly what it's doing. This first guy, second guy, time minus first index. So this is like, how far into the animation? Fmod time by sample count. Okay, I have to think about this one for a second. Is time measured in samples and not seconds? It seems that way. Yes. Yes, it is. Yes, so I would just explain that. Like, the time is in samples. Simple comment. Okay. Calculate pose transforms. Calculate joint transforms. I don't get it. I don't know what this is for. I would maybe just have a comment in here too. This is kind of the slow way to do all this, but it's a sample, right? What are we doing here? So I guess these were output. I'm just confused because it's saying calculate transforms plural, but it's only doing it for one joint. So what is even happening here? Skeleton joint.id. I have no idea. My brain's shutting down. I don't know why that's there. That just seems wrong or weird, or if it's not wrong, If this is somehow doing the whole skeleton, there needs to be a comment about why, because it looks to me like it's just doing one thing. Wait, we're for looping. Oh, there's like a. Oh my God. I understand now. Okay. Red alert, red alert. This is actually. This is actually recursively. My brain didn't do this. This is recursively iterating over the. Okay. Yeah, this is fine. This will do everything. This is not how you want to write this code, which is why my brain didn't process it. Yeah. This is the way they would teach you to do it in computer school. The problem is it's not a fast, tight loop way to do it, right? The way that you really want to do it is that your joints or bones or whatever you call them are just sorted by depth, right? From root to leaf. And you can do that when you load the thing. You can compute that pretty trivially, right? Although actually, right, you should probably do it in the exporter. And then you just know that your file format is sorted that way. And then you just do a for loop from 0 to the end. And you say, okay, what's my parent index? Get that transform. I know it's already been computed because I'm at a later index. So get that one, and then compute my local transform and multiply that together and set it in my thing. And it's a single loop. It's not a tree traversal. And you don't need to save this children data. I don't even know. This is like a for expansion for joint or something. I don't even know where that is stored. Hopefully it's not doing something n squared just to find the children. But in Sokoban game, it's literally just a for loop across the number of bones to do all of them in order. Preferred way to do it. Yeah. Okay. Again, sample program, I don't totally care. But it would be nice to at least say, actually, that's all. Okay, so that's that file. Let's look at the mesh file. How big is it? Moderately. Okay. Vertex. Ooh, only 3 weights per vertex. A lot of times people use 4. Why? I don't know. It's tradition. I guess he feels like he can get away with 3, which saves you 1 float per vertex, which is great, right? Okay. Joints. Okay, this I'm confused by. Okay. Here's what's happening, I think. Looking at this, it actually is 4 bones per vertex, but he doesn't store all 4 weights because I assume the assumption is that the weights sum to 1. So to get the 4th weight, you add the other 3 and you do 1 minus, right? It's a 50 DKP minus. And that's like kind of a common trick in games, right? You're trading off a small amount of computation because you know there's an invariant, I assume. And honestly, we probably should do that. We don't do that. This code assumes the 0 index is the root bone. Yeah, which is a common assumption, but that also means it's at least a little bit sorted, like I was saying, right? Because 0 index being the root. Okay. Skinned mesh, using skeleton, okay. Vertices, indices. I mean, again, ideally you would put these in one block of memory. That's a tweaky thing. I don't care that much. Okay. Local bind, inverse bind. I mean, parent, he's doing this to like keep these small, I guess, right? But you don't really want to store any of these in your runtime. He's explaining it a lot in a big comment, which is cool. I like that the rationale for using these is being explained, but like, you don't actually need any of these. Okay. Anyway. Okay, here's that for expansion for joint. My brain is getting tired. I'm still on Florida time, and I have a small amount of jet lag still. And also, I've been cranking all day. I did so much work today. So, you know, we're getting there. We're getting there. It's only 8:30 p.m. here, though. Okay. Nine floats versus 10 floats isn't a big deal when it would likely round to 12 floats due to byte alignment. But alignment is bad. Like, you don't want to waste memory due to alignment because that reduces your, well, if you're loading it straight out of a binary file, it increases your file size, but also it just reduces your memory, your effective memory bandwidth, because you're pulling in all this waste memory. And there's no reason to align things like that. Even on shaders in the old days there would be, but in new shaders, you don't want them aligned on the GPU either. It's not good for anybody. Okay. So the for expansion, it's going to be navigating those, you don't want to do any of this. Okay, we would use binary file formats, but this shows, okay. See, okay, this is a good, you know the kind of comments that I said before about I wish they were there? What I was wishing for is exactly like this. It's short, but it explains enough about what we're doing. For an example program like this, I wouldn't worry about a binary format. I mean, you could go either way. It's fine. The program would be shorter if it was a binary format because you would just like load it in. And you wouldn't have to have all the parsing stuff. I mean, you would have a small amount of parsing stuff to make sure the file's okay, but it would be way less. But you know, loading a text file is a thing that people want to do sometimes. So, you know, it's not too bad to have an example. This to me just looks like a big, again, I would use vertical spacing to indicate association. Like each of these things, what's even happening? So this is setting up the handler and making sure the file is at least something we can do. This is doing joints. This is doing vertices. This is doing triangles. Like, I would just break it up vertically because it just makes it more understandable. I don't know. You see my point. Okay, so it's reading all that stuff. This is more OpenGL stuff. I guess that's fine. I would probably throw that in the GL file, whatever that was called. Just because all the other GL stuff was there, almost all of it. Calculate joint transforms. For a skeleton? Wait, the other one we were looking at. Why is that different? Calculate pose transforms. Calculate joint I don't understand why these are different things. I'm not going to think about it, but that's my comment is I mean, calculate joint transforms, calculate joint transforms. Okay, so I guess bind transform, this is just saying getting the T-pose, I guess. I guess, okay. Sure. I mean, yeah. Okay, we've seen main, mesh, parse, render. We have not seen, oh, and we've seen anim. We have not seen camera. We have not seen UI. Let's look at UI. That's bigger. G-Police. So this is all the things that you edit with the UI. I think that makes sense. Update UI, a little bit of GL stuff. We get the monotonic time. It's split 64. We do per frame update, drop down, slider, checkboxes. Okay. Drop downs, meshes, boom. I mean, yeah. It's a little bit of a different style, like he likes one line per argument here for some reason. Although he didn't do that for other stuff, so I don't know, maybe when doing UI that's just the style here, I don't know. Anyway, this is just makes sense. This is how you use getRect. Totally makes sense. And that's the whole file, yeah. 100% makes sense. You don't even really need much more in the way of comments here. I would maybe put a comment at the top saying this draws the check boxes and drop downs and stuff, which will become evident to people as they read down the file, but just a little introduction to set the scene. Camera. Okay, this is even shorter, I guess. Camera, position, Euler angles, rotation, update flying camera. Is key down, cast no check key code. Do you really need the no check? I kind of doubt it, but okay. I kind of doubt it. Like, these are constants, and I think the compiler, even currently, will not generate check code in debug builds if it knows it obviously fits. If that doesn't happen currently, it should. But I believe it maybe probably does. So the no check is more like a sign that you don't totally know what's happening in your own code. And it makes it a little less readable. So I would not put that. That said, maybe character is signed, and maybe this is unsigned or something. I don't know. I probably should talk to him about it. Anyway, so this is just like casting from bool to float, which is well defined here. I don't think that's well defined in C, but here it'll give you 1.0 or O.0. And is it well defined in C++ now? Like in C++ 37, do they finally let you cast from bool to float? Chandler Carruth probably says no, because it lets you optimize sometimes, or whatever. Anyway. Here we go. Rotation, delta, Euler angles. Yeah, I mean, apart from style, this looks like very much like something I would write. Like he's updating the view projection like literally right here, but that's, you know, it cuts down on amount of code. Like, why not? Yeah, no, this is fine. Okay, so executive summary. I do think this would be a good sample program to have in the distribution. I just think, what notes did I write down? I would get rid of the meta program for the purposes of this sample. I would, like all the stuff about the bin folder and stuff, you actually should be able to set from a run directive. And that would be an interesting example of how to do that actually. Just put a run directive in main and do that. I would have a readme, oh, let's look at the rest of the files. Hold on. Well, no, let me finish this executive summary first. I would have a readme just saying what all the subfolders are and what the files are. I would have one more animation just for people to pick from. It's worth the extra data footprint. Okay, data. Mannequin.blend1. This looks like a mistake maybe. I don't know why these both are here. They're the same size. So I guess these are the source Blender files. Is the current Blender Blender 2? So is this exported for backward compatibility? Is that what's happening? How much do these compress? I think we distribute things as a zip right now. Yeah, okay. I mean, the thing is, this is kind of thick. I don't know if I want to distribute 2 of these with the compiler all the time. Okay, fonts. We got all these open sanses. I mean, if we don't use all of them, I would delete the ones we don't use just to keep the file size down, right? I mean, it's not that big, but we try to keep the compiler, like the whole compiler distribution is 200 megs right now. It might even be smaller since I deleted some stuff today. Let's look at what fonts are used here. It's in source. I guess it was in main, right? Font. Init fonts. So Open Sans regular and Open Sans italic are the only things being used. Yeah, so I would just delete all the rest. For the, I mean, he, you know, again, in his own version. I mean, I guess that's the thing is like, if we change this too much, then the example is, you know, drifting away from his production code over time, which means maybe it's hard if we ever want to update it. But I think, you know, I don't think we should distribute all those fonts. Okay, and then run forward anim and standing idle anim. Like, that's fine. Let's see how this zips. Maybe we should start 7zing the compiler. It's just annoying. Oh yeah, that way zips down. Cool. Int. What's int? Intermediate files, I guess. And source. Okay. Yeah, I mean, I think this would be a good sample. I think it's better than a lot of samples we distributed for a long time. For sure. I would just change the stuff I mentioned and put more comments. Really. That is the executive summary. Considering the compiler comes with several games as examples. I mean, we got rid of the games, a couple of them, because they were just old and not good examples, but there's at least one. Like Invaders is still there. You know, and this example is the quality level of a simple game. Would there be a stripped down version for people with bad internet connections? I mean, even people with bad internet connections can download 200 megs. Like, Braid was 150 megs literally 14 years ago. And like, it's fine. Blend1 is Blender's backup file. Okay. So we don't need that at all, basically. You can convert bool to float. Okay. GCC is 170 megs, yeah. Yeah, I mean, at some point, if the compiler gets big, we could offer a download that doesn't have examples and stuff, right? That would be my approach, is like maybe at some point when, if we end up having a lot of data files, which we might want to do to make examples nicer, I could see our distribution script putting together two different source trees, right? Or two different, whatever, file trees. Anyway, that was nice. It was nice to read through. So totally good code. Not the fastest code, but you know, when I wrote the animation system for my stuff, originally I actually did stuff that was way slower than that because I was like, oh, maybe I'm going to need to do this, and maybe I'm going to need to do that, and like, nope. So it's not a diss that it's not the fastest way. I have done slower things for sure. Anyway, that was cool. Like I like reading code when I like reading code. Question now is, do I attempt to do anything else tonight? I think maybe not. I think I don't know how long we've been going, but I think that might just be the stream, and then I'll go to bed eventually because I'm still kind of on Florida time. But are there any questions from the people? Any questions? Anyone? Will I do a review like his throw samples? Yeah, I mean, if the author of the samples okays it in advance, like I don't want to, you know, I want people to feel safe about sending me code and saying, oh, does this work, or what do you think of it, or whatever. But I don't want to expose it to public comment unless the person says okay, right? Because like if I don't like it, I will say negative things about it, and I'll say it in a politic way, but still, you know, you don't want to do that to people if they're not expecting it. In Sokoban, how does the material system work? Yeah, it's artist defined. So the way it actually works is like when they export the mesh from Maya or whatever editing tool, it has material names. And then of course Maya has a bunch of material properties that it thinks those material has, but we just ignore all of them because our engine just has a different set of material parameters, right? And so they then on the game side define what that material looks like, but you know, they can map it to a bunch of materials that they define and set parameters for and stuff. Will Sim3D work on Linux? Yes. Why are you even asking? Like literally everything works on Linux except a couple examples that are Windows specific. Okay, like part of the point of what we're doing is that it's cross-platform. Like we don't do things that are not cross-platform as standard. Okay. Yeah, you know, I might be a little too tired to do much more programming. Today was a big day. Today was a big day. What was the cast without the type in parentheses? I don't remember any cast without a type in parentheses. There was with a space and then a type in parentheses. But maybe I'm not remembering something. Do any beta users have program outputs in the physical world? I mean, there's a bunch of people doing a bunch of different things, and I'm not keeping track at that level of detail. It's like I hear about what people are doing, and I'm like, oh, cool, but like I don't remember everything like that. No, I think he was talking about, okay, key down. Where was that? Was that in main? Where even was it? Key down. I mean, oh, the cast comma no check. Right, is key down. Where was that? Was it in UI? No. No. Is key down? It's in camera. That makes sense. So it is a cast with type in parentheses, right? Here's the cast keyword. Here's the parentheses with the type. This is a modifier on the cast that says don't check for overflow, right? Just do the cast and don't generate an error if it doesn't fit. But like it does fit, I think. Oh, you know what? No, it fits. Like the thing is, these get desugared into integer literals, and it's the same as if you put like, you know, 65 here or whatever, and 65 just fits into the target type, and that is just defined. So there's no, as far as I know, there's no reason to put the no check. Okay. Thank you, everybody, for coming by and doing our little code review. I'll be happy to put this in the examples. I will reply and tell the author this. And yeah, I'll probably do some more streams on this trip. I'm in San Francisco, and why would I go outside in San Francisco? Thanks a lot. Well, let's try to raid somebody, right? Let's do that. That's always fun. So we could raid ASMR. Could raid Summit playing 1G Strike. bugs and guns, Go programming, code help and advice, SQLite 3, Fist of the Forgotten, Code Wars, making an MMO, mod pack development, exciting news plus record smashing stream, designing forest assets, React stock portfolio app, Leet code day 5. Do I want to know how to get a job at Google? Level design brings all the cool kids to the yard. I mean, yeah, it does. Yeah, it does.
Well, yeah, we could also just hang it from...
All right. Thank you, everybody. So we're going to go do some level design. And I'll see you all later on.